everyone, welcome. Today we'll look at inverse of matrix. Easiest way to find the inverse of a matrix is using the formula. Now I write that formula. Inverse of the matrix is equal to 1 over determinant A times A11, A12, A13, A21, A22, A23, A31, A32, A33. Using this formula, you can find the inverse of any arbitrary matrix. I'm going to explain these coefficients, but let's firstly find determinant A. Determinant A will be in this form: 1, 0, negative 1, 2, 1, 0, 0, negative 1, 1. So let's just calculate it. 1 times 1 times 1 will be 1, plus 2 times negative 1 times negative 1 will be 2. Then it is equal to 3. So determinant A is equal to 3. Now let's find these coefficients. A1 1 coefficient, that is it. It is equal to this value, negative 1 to the power of 1 plus 1, times, and a determinant. And the coordinates of this determinant, we'll use just this way to find it. Write the matrix again, just 1, 0, negative 1, 2, 1, 0, 0, negative 1, 1. Then first choose the first row and first column, and just cancel that element. So draw two straight lines which intersect at this point, first row and first column. So the remaining remaining coordinates 1, 0, negative 1, 1 will form a determinant, 1, 0, negative 1, 1. So that is equal to negative 1 to the power of 2 is 1 times 1 minus 0, so that is equal to 1. The next step is to find A12 coefficient. A12 is equal to negative 1 to the power of 1 plus 2, as you see, 1 plus 2 times, let's again do that, 1, 0, negative 1, 2, 0, 1, 0, negative 1, 1. In this case, first row and second column, and choose that element and draw two straight lines that intersect at the coordinates of the first row and second column. So the remaining point 2, 0, 0, negative 1 will be determinant in this case. So that is equal to negative 1 to the power of 3 is negative 1. 2 minus 0 is 2, that is equal to negative 2. Then let's find A13 in the same way. 1 negative 1 to the power of 1 plus 3 times, let's write it again so we can see it clearly. First row and third column, then 2, 1, 0, negative 1, so that is equal to 1 times negative 2, that is equal to negative 2. Now I'm gonna write the other coefficients quickly. Negative 1 to the power of 2 plus 1 times 1, 0, negative 1, 2, 1, 0, 0, negative 1, 1. Here, second row and first column, find that element. So just draw two straight lines. The remaining points 0, negative 1, 1, 1. It will be negative 1 times negative 4, sorry, negative 1 times 1. That is equal to negative 1. Sorry, this is negative 1. Then it will be plus 1. Then 8 to 2, it is equal to negative 1 to the power of 2 plus 2 times 1, 0, negative 1, 2, 1, 0, 0, negative 1, 1. Then second column and second row, that element, so remaining points 1, negative 1, 0, 1. That will be 1 times 1, that is 1. 8, 2, 3, it is equal to negative 1 to the power of 2 plus 3 times 1, 0, negative 1. So second row and third column, this element, cancel this element and draw two straight lines and cancel the element that is on the straight line. So the remaining point is 1, 0, 0, negative 1. That is equal to negative 1 times negative 1. It is 1 again, 1, 1, 1. So let's find A31, A32, and A33. A31 is equal to negative 1 to the power of 3 plus 1 times negative 1, 0, negative 1, 2, 1, 0, 0, negative 1, 1. Third row and first column, cancel this element, draw two straight lines that intersect at a point in the third row and first column, and then the remaining points 0, negative 1, 1, 0 is equal to 1 times negative 1, and that is equal to 1 again. A32 it is equal to negative 1 to the power of 3 plus 2 times third row and second column. Third row and second column, cancel this element, draw two straight lines. The remaining points negative 1, negative 1, negative 1, negative 1, 2, 0. It is negative 1 times 2, that is negative 2. The last coefficient is A33, that is equal to negative 1 to the power of 3 plus 3 times third column and third row and third column, cancel this element, draw two straight lines and cancel the elements on those straight lines. That those straight lines intersect at the point third row and third column. The remaining points, remaining coordinates will make a determinant in that coefficient. Negative 1, 0, 2, 1, that is equal to 1 times negative 1, that is equal to negative 1. Actually, that's not negative 1, so it is positive 1. And we found all the coefficients here, so we just have to find this inverse. So let's write it here. It can be seen here. A inverse is equal to 1 over determinant A. We just found that determinant A is equal to 3, so 1 over 3 times, let's write this coefficient. A11 is equal to 1, A12 is equal to negative 2, A13 is equal to negative 2, A21 is 1, here A22 is 1, A31 A23 is 1, then A31 is 1, A32 is negative 2, A33 is 1, yes, is 1 here. So now the last step is just multiply this matrix by constant 1 over 3 1/3. Then it will be just multiply every coordinate with this 1/3. Then it will be 1/3, negative 2/3, negative 2/3, 1/3, 1/3, 1/3, 1/3, negative 2/3, 1/3. So that is the solution, and this matrix is the inverse of this matrix. That is the inverse of the polynomial A matrix. So that's the solution of this task. I think that this is so easy way to find it. I hope that this helped you. If it helped, please let me know in the comments. If you like this video, please hit the like button and leave a comment to support me. I make this kind of mathematical videos on my YouTube channel. You can check them out. So thank you for watching this video, and don't forget to subscribe to my YouTube channel. Thank you very much for watching this video until the end. Thank you very much.